Hello, class. In this continuation of the topic that we were covering before, the straight line, now we're gonna see other examples of how to transform from one form to another. As you may remember, the straight line has three main forms, for its equation, which are these ones, right? This, and this. Remember, this is the slope intercept form. This is the point slope form, and this is the general form. And in the previous lesson we went from this one to each of these two, from the slope intercept to the point slope and to the general form. I'm going to show you two examples of how to go from the point slope to each of the other two, and from the general to each of the other two. By the way, why did I write this in between parentheses? Because often you don't have to add the adjective straight in order to specify that you're talking about a line. In mathematics, whenever you say just line, we understand that you're talking about a straight line. If nothing else is added to the pronunciation, we understand that you're talking about a line. So you don't have to add this adjective every single time you want to talk about a straight line. Okay, so let's go ahead, guys. This one. Let's get this form of the equation, which is remember the point slope to each of the other ones. So let's do this. So my equation of origin is this, and I say that this is almost in point slope form. It's pretty much there. Why do I say that? Why do I say that it's pretty much the point slope form? Because you have to have everything in exactly the form that the equation is giving you. If you notice, the form looks exactly like this, which I'm gonna copy here. It begins with a y, and then it has a minus, and then it has this constant equals slope, which is a number, times x minus another constant. And if you notice, this equation, even though resembles this a lot, is not precisely in that way. So if I want to put this in precisely the slope form, I'm gonna have to have a change right here, guys. In this way, look. I'm gonna write y, and I'm gonna transform this plus 5 into this. Look, minus 5 equals 6 times x minus 2. And if you notice, now this thing has exactly the form that I'm being specified here, the point slope form. Y minus some constant, y minus some constant, the constant can be negative, no problem about that, equals some constant which represents the slope, you see, times this binomial which has the form x minus something. So this is exactly the point slope form. Okay, so let's transform this into first the slope intercept form. If you notice, it's very simple, guys, because basically you can understand this form as just isolate y or isolating y. That's all you need to do, right? If you isolate y, you end up pretty much with the slope intercept form. So I'm gonna take this and I'm gonna isolate y. I'm gonna write y equals 6x minus 2, and then I'm gonna write plus 5. No, I'm sorry, that's gonna be minus 5, right? Yeah, it's gonna be like this. Actually, you can start from here, right? No problem. I just wanted you to know that this is not exactly the point slope form, not exactly, it's this. But then if you start from here, you just subtract 5 from both sides and you're gonna arrive here. Now, is this form? Does this have the same form as this? Look at them. Clearly not, right? Clearly not, because in here the x is not within a binomial multiplied by a constant, right? So we need to change this a little bit. What about doing this? What about multiplying this 6 times this binomial? So we get 6x minus 12 minus 5. And what about adding these two numbers? We get y equals 6x minus 17. And we're almost there, right? Can you see? Almost. Except that I have a negative here, I have a plus in here. So technically speaking, we should write this down. Y equals 6x plus minus 17. These two things are pretty much the same thing, if you notice. In this way, I'm just making sure that it looks exactly like this. But most people would say that this is also the slope-intercept form. So both are okay. Both are pretty the same thing. Okay. And then what about the other? What about bringing this into this other shape? Well, let me begin also with this equation. Let me make a okay, like that. And if I notice, the general form has a 0 on the right, so let me bring everything to the left. So I already have the 0 on the right. And let me continue. Let's see what happens if I multiply this minus 6 times this parenthesis. I'm gonna get this. Right? And then this almost looks like the general form. Almost. All I need to do is rearrange some terms and maybe add 5 and plus 12, and I'm basically done. Minus 6x plus y plus 17 equals 0. And I take a look at this, and I take a look at this, and I go like, okay, that's it. This is the general form. Why? Because it has exactly the same shape. Exactly. We have a coefficient times x. In this case, my coefficient is negative, no problem, times x, plus a coefficient times y, plus the coefficient which is 1, times y, plus some constant, equal to 0, equal to 0. There you go. This is the general form. So we have brought this original equation, which was, I repeat, was almost in the point slope form. This is technically the point slope form. And we brought it down to look like this and to look like this. Remember, this equation, and this equation are all the same. It's only the shape, it's only the presentation, so to speak, that is different. Same thing, different forms. Okay, now copy this one. I want to do this one with you in class. 2x minus 1/2 y plus 3 equals 0, and we're gonna bring it to look in the slope intercept. Remember, try to memorize the names. I know they're a little tricky. This is the slope intercept form. This is the point slope form, and we're gonna bring this one to look like both this and this. And then after that, I'm gonna share the workbook with you, in which you're gonna perform several exercises of this exact process. Okay, thank you guys.